Hello, everybody. My name is Sergey, and I will be a moderator for today's session. I would like to remind you that you can post your questions in the chat, and I will pass them to a presenter a little bit later. And also, I would like to note you that today's session will be recorded, and you will get a link after it ended. Let me present you our next speaker. His name is Artem. He's working as a project manager at EPAM. Has more than 7 years of his experience in IT and about 10 juniors that he had on his project, and he's now a good, mature engineer. So, Artem, welcome, and my word is passing to you.
Hi to everyone. So let me share my screen. Hi everyone. My name is Artem, and I'm a project manager in EPAM Belarus. Despite I'm now a project manager, my biggest part of my career was connected with test automation. So not just engineering, but combining it with team leading, resource management, compensation management, and so on and so forth. And now I've grown up into a project manager. Besides, I'm our test automation community department, so we're conducting events each month, but we'll talk in details about that a bit later. So, some speakers love saying that you can see my experience, so you have to trust me, but actually, personally, I don't want to trust you each my words. Just because my main idea today, my main goal is to make my words helpful and useful for you, to make you to reflect and rethink the approaches you use, the approaches you've used before, and why did you use them. And so I really hope that my words would help you to rethink your way you're doing the test data management now. So let's go through the agenda. So first of all, we'll go through my own rating of test data management approaches. And finally, we'll try to extract the main characteristics of an ideal approach. But that's not will be the end. We'll also go through code samples of the highest rated approach, per my opinion, and we'll discuss some solution that we usually miss. But before we start, let me give you a bit context about what we'll be talking about. So first of all, I consider test data management consisting of two parts. So the first one is kind of data supplied by a test. So it means that if we're using boundary values test design technique, so we have to set one value, 100 value, and so on and so forth. So this is the data that the test sets and how it manipulates your application, your test environment, and so on and so forth. But today we'll be talking mostly about precondition for your test. So how do we create them? How do we manage them? Is it automated or not, and so on and so forth. So this is the thing. Also, my main assumption for today is that all the tests that you have should be independent and use its own data. So personally, I don't expect tests to have some kind of dependency that one test should be run before another because it prepares some data for it. So that's not how it should work. So each test should use its own test data set precondition. So what we'll not be talking about, it's also important. First of all, we'll not be talking about licensed tools. So licensed, expensive tools, that's not about today. We'll discuss just the approaches that can be implemented by your programming language and kind of open source tools. Also, we'll not be talking about silver bullets. So I really believe that there are no best practices in the world, but there are some good practices that can be applied to a specific context. So all the approaches we'll be talking about, they won't be able to suit any context, any project, any situation. So all of them have some constraints. And finally, we'll not be talking about some kind of a rocket science. So all the things, I hope that you'll find them quite obvious, quite easy to implement. and probably you even know most of them. So I really hope that it will be like this. So let's start. So let's start from my own rating of the approaches. But before we go to the rating, actually, personally, I separate all the approaches into two categories. So the first one is prayerful and the second one is prayerless. Talking about prayerful is mostly when you have to really pray that your test data is okay, that it's not changed, that it's not broken, and you're not actually sure about it. And here on the right, you can see the common phrases that you can hear from the engineers that are using such kind of approach. The second one is prayerless. It's when you're much more sure about your approach, about the way you manage the test data, the precondition, and so on and so forth. So at least it should be automated, but we'll discuss it later. So let's start. And the first prayerful approach, which is the last place in my rating, is manual preconditions preparation. So actually, this is probably the one that I love the most because I've started with it when I went to my first job. Half of my work time was spent on manual precondition preparation. So I really have a good experience in it, unfortunately. But anyway, so the main idea, so if you have, for example, the web application, you take both of your hands and just create all the preconditions via the interface using your hands manually, and then just somehow hard code the data in your tests. So what are the benefits of such approach? So at least it's easy and visualized. So it's the thing that can everyone do. So it also can be delegated to non-technical stuff. So even your children sometimes can help you with this. And even if you could delegate such kind of activity of the whole precondition preparation to another person, so actually you're the winner and you can leave managing the preconditions because you have nothing to worry about anymore because another person will do it instead of you. So actually you're an awful test automation engineer, but you're a great manager and it can also work. But generally the problems are really important. So first of all, that this approach and the data you create in this approach is not protected from changes. What do I mean? So first of all, I hope that your tests are actually doing something. So if they get some data as an input, then they should manipulate and somehow edit it or update it. And then this data will not be suitable for the same test and you have to reconfigure it one more time. And the second example connected with this problem can be visualized by this picture. So when I started working, so it was a very common dialogue. When I have prepared some kind of test data, I hard coded it into my test. It was working, but suddenly the test failed. I'm going to my colleague and he or she said that, oh, that user was just breaking my test, so I've deleted it. And this is the thing you can't manage. So you can't always manage other people, your colleagues that may even accidentally spoil your test data. So another problem is that it requires frequent backups. So what do I mean? So imagine some test automation engineer called Jack. So he has developed 1,000 tests. So it means that he has created 1,000 tests of preconditions. So for each test, and finally, Jack thinks that he's cool, so he's done the job. But finally, the disaster happens. So test environment falls down. For example, the database died or the cloud died. Someone has deleted your test machine in the cloud. And so that means that Jack has to restore 1,000 datasets manually. And here is the Jack after that. And the problem connected with the previous example is that it's easy to forget details. So imagine Jack who has to restore 1,000 data sets and he has to keep in his head what did he need from his test data, from his preconditions, which he created a year ago. So that's not an easy thing to remember unless you documented it anywhere. But from my experience, not many people do documentate such kinds of things. So that's quite everything about this. So let's move to the place number 6 about using data from production. It's kind of an enhanced previous example, but when you don't want to create all the data manually and you hope that you will find the necessary data in production like databases, of course, obfuscated, and you can hard code them in your test and somehow use them. So the benefits are quite obvious. So again, it's easy, it may contain a lot of various data, and it shows how users really use the application, and it can be useful for you to design your test. Sometimes it can work. But anyway, the cons, the constraints are really important again. So it's not protected from changes as the previous one. It's easy to forget details because it would be hard to remember why did you choose such kind of test data a year ago, and it's not easy to replicate manually if the test data is broken. So, and another important problem is that important cases may be absent. What do I mean? So we are all QA engineers. We really love edge cases. So the cases that will never happen in the real world, but we are testers. We have to submit this bug and we have to make the developer to fix this bug. But that's our job and that is okay. But the problem of such approach that, again, not all the situations can happen on the real world, in the real world, but we have to check this. Another issue is that each new consuming from production may be difficult and harmful for your tests. So what do I mean? Let's come back to Jack. He has again developed 1,000 tests. He has found 1,000 appropriate data sets on production. So he's not just a good engineer, he's a lucky guy. Then he decides that he has to write new tests. So it means that he needs a bit more data for new tests. And he thinks that it's a good idea to get back to the production and consume the new data. But suddenly he realizes that the user, which was used by his 200, for example, of tests, has deleted his profile. And there is no such user and all the data that this user had in the database. And so Jack has to find some kind of new user. And here is Jack again. Okay. But Jack is a clever guy, so he thinks, but what if we search for it automatically? So we have a lot of data, and we don't want to hard code it inside the test. Let's search for it automatically using, for example, searching in the database directly. And that can work, but it won't solve the problem when you're covering some edge cases that can never happen in the real world, but you have to test them. So the problem still remains. So let's move further from the totally prayerful approaches to semi-prayerful approaches. It's test data creation via Selenium. I think most of us have used this kind of approach, and the idea is simple. So if we're testing web application, we're not just testing it via Selenium, we're also creating the test data using this technology. And the benefits are quite obvious. So at least it's automated and it's much better than the previous two approaches. So it provides clear and reproducible data details. What do I mean? So if you want to reproduce some situation for submitting a bug, you can just look through the code that creates the precondition and you understand that code. So you're test automation engineers, you understand it, and you can just recreate it manually to show it to the developers, for example. So it's easy to understand because we'll work with it. It also performs implicit functional testing. So what do I mean? So if you are performing some precondition actions via Selenium, you are retesting your application, so the functionality that creates or manages some entities in your application. And you may find some bugs that can be useful for fixing in the nearest future, some important bugs, for example. And of course, data is not lost on test environment change. So if your database dies, you'll never worry about it because Selenium will recreate all the test data you need. But the problems, again, are quite important. First of all, it's unstable and very unstable. So we all know that Selenium is not the most stable thing in the world. And to visualize that, let's go through a small mathematics. So let's imagine that success probability of each Selenium step is kind of 99.9%. So then we want to develop a really small test that contains of 10 Selenium steps, for example, click, find elements, or get text, and so on and so forth. And its combined success probability will be a bit less, 99%. Then we want to add a precondition. But in my experience, preconditions are usually a bit bigger than tests because you have to specify many properties specifically for this case and so on and so forth. So its stability even worse. So let's imagine that it has 20 Selenium steps and its total probability is 98%. And then we want to take precondition, we want to take the test and combine them. And finally, we get the total success probability of your test combined with the precondition of 97%. So what does it mean? It means that you will have 30 tests that may fail, may not fail, you're not sure about it, 30 such tests out of 1,000. It can be a big number for your project. It can be a small number for your project. It depends. But anyway, the main idea that for our specific example, adding a Selenium-based precondition tripled the stability issues. And in my world, it's not how it should work like. Okay, let's move further and let's discuss another important issue of such approach is trusting the system under test. So previously we've discussed that you can find bugs via Selenium precondition and that's good, but that's not always good. So in ideal world, you should not trust the application you are testing, the system under test, just because. Let's come back to Jack. So Jack wants to run 1,000 tests that he has just developed. So it means that, for example, all the tests have some specific preconditions and they all need some specific data to be created. And finally, the precondition contains a bug. So for example, create button became not clickable. So in ideal world, only those tests which are connected with the create functionality should fail. But in your case, all tests become failed because all the precondition failed. And that's not good for your stability, combining with the stability of Selenium, you remember. And here is Jack again. Let's move further. So we ended with prayerful approaches. Let's go to prayerless approaches, which are at least automated. So first of all, place number 4 is SQL or not SQL. So it depends, but that's, for example, SQL insertions called directly from the test code. So the idea is simple. So each test in the very beginning calls some SQL or no SQL query, which will create the necessary data. So the benefits are quite obvious. So at least it's automated and it's really fast. And also, it's very important that you don't trust to the system under test because you're diving to the lowest level possible. So it's not even API, it's directly database. But the problem still remains the same. Not actually the same, but it's not easy to maintain such kind of approach. So first of all, it needs constant maintaining just because each time your database scheme being changed, you have to update, you have to migrate all of your queries. At the same time, I really believe that such approach suits small applications only, just because imagine you have a huge application with hundreds of tables with a lot of connections and links between them. And when you create one small entity, it can require insertion into 10 or 20 tables. And you can imagine the size of such a query. And that's for a single test. So when you have 1,000 of tests, it would be absolutely unmaintainable. And so that could be a problem. But if you have a small application of kind of 5 or 10 tables, if it is possible in current world, so that might suit you because at least it's automated and fast. So let's move to the top 3. So the bronze goes to managing data snapshots. And this is kind of the manual approach combined with constant backups. Let's go through it. So first of all, you create the precondition data manually on your test environment. So then you create a database snapshot, so kind of a backup. And then before you want to run each test, you have to clear all the data from the current database. You should roll out the snapshot so it would create the necessary data for your test, and then you'll run the tests. So the idea is simple, and each time you want to run the tests, you are again performing this cycle. So clearing the data, rolling out the snapshot. That's how it works. So the benefits are quite obvious. So it's easy to roll out. It's half automated, so it should be maintained manually. But anyway, again, no trust to the system under test, as we're diving into the lowest level, you remember. And finally, data is not lost on test environment change. But what about problems? So first of all, unclear data details. Again, if you want to remember which test data set was created in the snapshot a year ago, it would be hard for you to remember unless you documented it. So it's really, it's really hard to integrate multiple engineers' work. So to integrate various snapshots one with each other, there are a lot of problems with it. It's really hard to maintain because, again, when you perform the migration, the database scheme change, you have to maintain it. And let's go to the place number 2. Silver goes to managing preconditions via object relational mapping. So for those who don't know what is ORM or ORM-like tools like Hibernate, so imagine you have a database. It has, for example, some table, let it be, and it has some columns. The idea is the following, that you are describing the database scheme using your programming language and entities inside it. So here is the simple, for example, event entity, which has some fields, kind of ID, title, URL, the creator, and so on and so forth. And all those fields are mapped with the corresponding ones in the database. And this is how it works. So again, you create the entities in your code, in your programming language. Then you map them to your database structure. Then you manipulate your entities objects. I mean, you create a new object, you call some setter methods that edit some properties of your Java or not Java objects, and then Hibernate or another object relational mapping like tool transfers all the changes to the database. So this is how it works. The benefits are really great. So first of all, it's absolutely automated. It provides clear and reproducible data details because you can see what you are doing with your Java entities, and you can replicate the same manually or not manually. So it's kind of a self-documentation of your preconditions. So you can replicate that. So it's really easy to understand. It's really fast, except of the moment you connect to the database for the first time. But talking about problems, they are also quite important. So it's really hard to set up for big applications. So if you have, again, 100 or 200 tables, you have to recreate all of them. You have to reflect all the relations between your tables, between your entities, one-to-one, many-to-many, one-to-many, and so on and so forth. You have to do it via your hands. But generally, it is a manageable task, so you can perform it. And also a very important point that it can be somehow a copy of developer's code. So if your application and your tests are based on the same programming language, so you can use some kind of life hack. So probably you may ask your developers that they have already done this task for their purposes. So they've already created all the necessary models. And if it is technically possible on your project, you can consume their model somehow as a Maven or Gradle dependency for Java, for example. If not, you can simply copy their code and updated on every developer's change, but that won't require you to recreate all the models by yourself, not to do the job that is already done. And before we go to the winner, let's try to extract main characteristics that we require from the ideal precondition management approach. So at least it should be automated. So it should be really stable, so not Selenium-like. It should be able to provide clear details. So it should be kind of self-documented. So if you see the code, you should understand which data and why it was created, which properties does it have. So it should be easy to set up and easy to maintain. It should be really fast. So like working with the database, for example, not with UI using Selenium. Data should not be lost on test environment change. And finally, in ideal world, you should have absolutely no trust to the system you are testing. So those are the characteristics. And let's go to the winner. And my winner is managing preconditions via application API. The idea is quite the same as the previous one about Hibernate, for example, but changing it with API. So again, you create your entities in your code, then you bind every object change to an API method call. You manipulate the entities objects, you create new, you added the existing, and finally the API should correspondingly manipulate the data. So to understand this better, let's move to the code samples. So I will show the examples based on our CommunityZ website. So it is the website, it is the platform where you could find our today's event, QAZ dates. So here you can see the following kind of cards, and those are events. So for example, they have the following properties. So QAZ days is an event title. On the below, there is a description. It has also event dates and some language, so let it be. And let's work with it. So let's go through the case number 1 about creating the new event. So here is a piece of code. It is simply a constructor of the class called event model entity. It receives quite a lot of parameters. That's not good, but anyway, it receives quite a lot of parameters which should be passed from your tests. What it is doing next? So it transforms all your parameters to some JSON, and finally it executes the post request, which should create the new event for you. So the main idea is the following. So executing the constructor, so for example, new event model entity with some parameters, triggers a post request, which creates a real event on your test environment, which is customized according to past parameters. So this is the main idea. Let's go to the case number 2 to understand it better. So let's test an ability to change the title of an already existing event. So here is the piece of code, and let's go through it. So the first line, it's again the call of the constructor, which creates a new event via API, as we've discussed before. So the second line is we're opening the necessary page in admin area in your browser. So it's important that we are moving to the browser. Then you are performing the action you actually want to test. So you are changing the title using your web UI, using Selenium or other tool that can perform that. And finally, you perform the assertion. You check that new title has appeared in your database. And you may ask me, so Artem, on the previous slide, you've shown a constructor that receives quite a lot of parameters that customize your event. Why do we see default constructor here? And the answer is quite easy. So from this specific case, we don't require anything from the precondition unless events to be existing. So it should exist, and we'll just change its title. So we don't need to specify these tons of parameters. So we can change all of them with the default ones. So the relation is the same as between default and non-default constructors. So default constructors default constructor creates an absolutely default event that we can work with, and it can also work. But you may again ask me, but what if we don't need such a detailed customization like here? But we anyway we want to specify to change one or two properties of our created event. And now let's move to the case number 3 to explore how it can be done. So let's check an ability to set English language of an event. So let's think, what do we need from the event that is created as a precondition? We need it not to be English, so that we will be able to set English, obviously. And so this is how it can be done. So on the first line, we create an absolutely default event. So we don't want to specify a lot of parameters. And then we just change the created object. So we set the new property, the new language to English, or to Russian, sorry. So it should not be English. So in this case, we are sure that we have created a Russian event. And then everything is like in the previous example. So we're opening our event in the browser, we're setting new language via web UI, and finally, we're checking that new language appeared in our database. So let's deep into this method. So what is set language method doing? So it's quite simple. Again, we are preparing the JSON for the request as it was in the constructor, but we execute not the post request, but the put request, which will update one single property. And the idea is the following. So calling the setter method, for example, set language, it triggers a put request, which updates an already existing event on the test environment according to the past parameters. And that is the main idea. But you may ask me again, but what if my web application, or not web application, doesn't have such a comprehensive API? And here we go to the solution that we usually miss. And let me now switch to my browser. I hope it's sharing. And let's, here is again Community.Z website. Let's go to the admin area and see how can we cope with it. So let's press add event button and specify some data for it to be created. So join.community, for example, just a random name. So let's check any language. It doesn't matter which data we set here. It's just for it to be created. So here it is. Let's check an empty template. And here we see the create event button. So before we press it, let me open our development tools. And we're going to the network tab of our browser. For example, Google Chrome in my case. So, and let's press the create event button. Here we see something happens, some new requests appear, and here we see a very interesting request, which is called events.json. So let's open its details, let's expand it for you to understand it better, and let's dive into the details. So here we see some request URL, as always, and here you can see that it is a post method, like we've discussed before. Let's go deeper. Let's go down to the parameters that are being specified by this request. We go here, and what do we see? We see a real JSON which has all the parameters that we have specified on our web UI. So it generally reflects everything we did just manually. And here you can see the same title, the same URL, the same dates as we have just specified. And what does it mean? So that is not a public documented API. That's an HTTP method that is used for our front end and back end communication. And if it's not the public API, if it's not somehow documented, you can use it if you have it. So you can use it instead of the comprehensive API that is already documented, and so on and so forth. So here is the same post request, which may create new data for you. So the only thing you have to cope with is authentication token, but you can take it from the cookies when you log in. So that won't be a problem. Let's check another example. So let's not create, but edit some property of our event. Let's go to some tab and let's clear it here. And let's, for example, change the title. So rate my talk after it ends. Again, random title. Here we see that autosave worked and a new request appeared. So called update property. Here we go into the details again. Here it is. We can see the put request. We can see some URL. We go to the bottom and we can see the parameters that being passed. So the field updated is title, and the value we want to set is the one we've set via UA. So again, if you don't have a documented API, you can just explore how your front end communicates with your backend and use such methods if they are suitable for you. So this is the way. So let's move back to the presentation and somehow wrap everything up. So here the 8 points we've discussed before that we expect from the ideal precondition management approach, and let's map them to the approach we've just seen. So here are the 7 points. So first of all, it's automated, it is stable from my experience, it produces a clear and reproducible data details, it's easy, it's fast, and so on and so forth. But you remember that on the previous slide, we had 8 points, but here are only 7. Because there is the problem that still remains, that we're still trusting the system under test. So API is the thing that should also be tested, and it can also have bugs that may affect your test stability. But from my personal experience, it was kind of a compromise between it being easy and being stable. So that's why I've put it on the first place. But anyway, there are some constraints. First of all, this approach won't suit you if trusting the system under test is absolutely unacceptable. So if your application is has absolutely zero bug tolerance, so for example, if you're working with medicine applications, which affects people's lives, you should not have any bugs. So you should not trust your application in any kind of way. So the second point is that if you are unlucky and you don't have any API at all, so even hidden one, so that I have nothing to suggest you except of going to another approaches that we've reviewed before. And finally, it will not also suit if most of your data comes from kind of an integrated service you have no access to. And so actually in this case, you have to work with some kind of mocking data, mocking instruments. And if you want to dive in it a bit more details, you can join our test estimation department community. We have conducted an event last month where this topic was covered, and you can find the recording there and somehow to observe the topic. And generally, we're making our events, we're trying to make it each month. We're talking about technologies, we're talking about our success stories and the ways you can continue your career path. So I think you could be interested. But going to the conclusion, let's summarize our winning approach. So the idea, one more time, is the following. So you create your entities in your code. Then you bind every object change, every creation, every its setter method calling. You're binding it to an API method call. Then you manipulate the entities objects, you create them or edit somehow, and API manipulates the data. And finally, here is Jack, and he is happy now. And so my main thought is that you can be prayerful person in your life, but personally, I think that you always should be a prayerless person in your job. So thank you, and please rate my talk on the community that it would take just a couple of seconds. So I think I am done. Thank you for listening, and I'm eager to listen for your questions.
Thank you, Artem. Thank you very much. Take a deep breath, like you did really great. Thank you. Thank you once again. During the session, we had a couple questions. Also, a few guys just sent us a private thank you note to your talk. They really enjoyed it, and they said it was useful. So
That's a pleasure.
yeah, your experience is really great. So there is one question from me that I would like to start from. Like those 7 ways to create test data. Did you use all of them in your work?
Fortunately not. Not all prayerful approaches were used in my experience. For example, I've never used approach when we consume data from production. Also, I have never worked with my own hands with managing database snapshots, but actually I was working as a technical consultant for a bunch of projects, and I have seen engineers that were coping with such kind of problems or not problems. And so all of my speech was based on such kinds of experience, my own combined with the things I've seen in the projects of other engineers.
Okay, thank you very
Camera.
much.
Sorry.
Yeah, don't worry, it's okay. There was also a point from one of our viewers regarding like using entity framework for C#. It's basically the same idea that we talked about, like ORM using stuff, but for C#. So what do you think, like personally, using ORM or using like API? If they're both good versions, or you would still prefer just doing API all the time?
As I mentioned before, there are no best practices again. So there are some contexts wherein you won't be able to use API approach. So as I've mentioned. So and here, for example, if you are working on the life care, healthcare projects, when you can't allow yourself to miss a bug, you should not trust the application you're using. You should not trust the API. So that you have to dive on the lowest level to the database. And so if your application is not very complex, is not so huge, so using the object relational mapping tool would be suitable for you, but sometimes it can be difficult. But anyway, as I've mentioned, you can try to consume your developers models, your developers kind of ORM solutions, and somehow reuse them. But sometimes, again, it's not always applicable. Not all projects have such kind of implementations.
Okay, thank you very much for your answer. We just received one more big thank you note for you, and it's always
That's
great.
a pleasure.
Yeah, it's always great to know feedback from audience. Don't be shy if you have any questions. We're still waiting for them, but for now, I think that will be it. I would like to remind you that the session was recorded. There will be a record available by the link later. The presentation itself will be also available, and if you have any questions even after the talk would end, you can send us a feedback form, a note through a feedback form, and we will do our best to answer it. And we have one more question. Let me just read it. Okay. What about integration testing? Do you have to prepare data for all the connected services? And what is the mock use policy regarding data preparation? So 3 questions in one. So let's start with the first one. How do you approach the integration testing for data preparation?
So it also would depend on various parameters. So first of all, whether you have a right access to the integrated service, or whether you can retrieve such kind of access. If yes, you can implement one of those solutions that we've discussed, but working with integrated application or integrated service. But that's a really rare case when you have such kind of access. So if you don't have such an access, From my experience, it's a good idea to think about mocking the data. So if the amount of data that come from an integrated service is not really huge, and it's possible to spend time to build the structure that will be able to mock the data for you to be able to manage all your preconditions, to able to manage all the cases possible. So I would prefer mocking the data. So for example, talking about Java, it would be WireMock tool. So it's the best one that I've used. But if, for example, the integrated service provides you a really huge amount of data, which is absolutely unmaintainable. You don't have the right access to create or edit such data for your cases. So that can be quite a problem. Just because you don't have flexibility. So there would be a point for you to adopt your test strategy, whether what you are testing, which cases will you be able to cover based on the data that is already present on the integrated service. And it would be also a good approach to communicate with the development or management team of such service, to collaborate with them, to join their API if it is possible, to create some data and so on and so forth. So this can be the good way. So I hope that I've answered the question and not pouring so much water.
Yeah, thank you very much. That was a really detailed answer, and thank you to Evgeny for the question. It was really a great question as well. So for now, I think we don't have any questions that were unanswered from our side. I would like to thank you one more for your time and for sharing your experience with us. It was really great, and hope to see you at the next KZ Days.
I hope so.
Yeah, it would be great to hear from you once again. Thank you one more time for our audience. You are great. You are the best, and don't be shy. Yeah, don't be shy to join to our other sessions as well. We have great topics that will be upcoming today, tomorrow, and the day after tomorrow. So 3 days of great QA talks. So thank you once again. Have a nice day, and see you later. Bye bye.
Thank you for joining. Bye.